Hello and welcome. My name is David McElroy, and I am the session moderator for this session. Firstly, I'd like to introduce you to Research Director Caroline Chappell and also Principal Analyst Michelle McKenzie. They will be presenting the session titled 5G-Driven Industrial Transformation, the Operator Opportunity. Now, if you do have any questions, we absolutely welcome those, and you can ask these throughout the session using the Q&A widget, which will be located on your screen. Just so you also know, the slide pack is not going to be available as a download, but this session will be recorded and will be available on demand later today. So I think we should get started, and on that, I will hand over to Caroline. So Caroline, if you go ahead whenever you're ready.
Thank you very much, David. Well, hello, wherever you are in the world, and thank you for attending our presentation today, 5G-Driven Industrial Transformation, the Operator Opportunity. I'm Caroline Chappell, a Research Director at Analysys Mason, responsible for our cloud and platform services research, including edge computing. And with me is my colleague, Michelle McKenzie. Michelle, would you like to introduce yourself?
Yeah, hello everybody. I'm Michelle McKenzie, Principal Analyst and Lead for our IoT research.
Thank you, Michelle. So we'd like to discuss 3 points in our presentation today. First, there are strong drivers for industrial transformation, including the current COVID-19 pandemic. But we'll explain that this transformation is happening in 2 phases. The advanced operational use cases that will make new demands on connectivity and compute will emerge in the second phase of industrial transformation, now beginning to be called Industry 5.0. These demands are beginning to translate into industrial interest in private cellular networks and edge computing. And in both technology areas, operators have strengths they can turn into opportunities. However, other interested players also bring capabilities to the industrial transformation table, so it's likely to be a crowded one. We'll examine what operators will need to do to differentiate themselves within the market. Most large enterprises in developed markets have started transformation programs, and in many cases, as this slide shows, their transformation initiatives have been underway for several years. We surveyed over 200 large enterprises in 6 verticals across 4 country markets, US, UK, Germany, and Japan, in both 2019 and 2020. And one of the questions we asked was about their timescales for transformation. You can clearly see the progression over the past year. Most enterprises are in the first digital phase of industrial transformation. This is all about digitizing the massive amounts of data they produce and using more of it in better ways to drive processes and create new digital products and services. Data-driven transformation, known as Industry 4.0, is driving greater use of the public cloud as a central repository for the sharing and storage of data, and the implementation of new shared digital thread and twin systems that help with real-time access to and the real-world modeling of that data. Enterprises are pointing out that the pandemic is accelerating the pace of their investment in digital transformation. FedEx, for example, recently spoke about being slingshotted into 2023 in terms of its cloud capacity needs, as it fulfilled demand for 1 billion masks and other e-commerce items so far in 2020. But digital transformation is also necessary for the next stage of industrial transformation, Industry 5.0. Industry 5.0 will use data to drive new levels of automation, collaboration, and experience, supported by intelligent connected machines of all kinds. The importance of sorting out a data strategy through digital transformation before the really interesting low-latency, network-oriented Industry 5.0 use cases can happen was brought home to Michelle and I in a call recently with the CTO of Peachtree Corners, a smart city on the outskirts of Atlanta, Georgia. Peachtree Corners has been designed as a living laboratory. It's the first city in the world to have a road system on which both driverless and driven cars can coexist. The CTO pointed out that at each intersection along a 3-mile stretch of that road, roadside units, cameras, traffic signals, and vehicles generate 2 terabytes of data every 2 weeks, which ideally needs to be collected and digitized in real time so the city can make decisions about traffic flow on a system-wide basis. And that's without the experimental data from the delivery drones, the solar roadway that charges electric vehicles as they drive, environmental sensors, and US Secret Service hacking events, all taking place in the city. Big data aggregation and processing is a key challenge for Peachtree Corners and highlights the need for IT-led digital transformation as a prerequisite for the operational transformation behind Industry 5.0. The killer use cases that will drive investment in operational transformation are difficult to identify at this point. There are thousands or even tens of thousands of completely new operational use cases, and most are specific to a vertical, a sector, or even to a particular company, even if they use the same set of technologies such as mixed reality and AI. But we do see Industry 5.0 use cases falling into 3 main categories. Use cases that change the experience of users, for example, transforming the way employees work, and therefore the experience they can give to customers, or transforming the direct experience that customers have of a particular environment, such as a store or a hospital or a tourist attraction. Collaboration is likely to be a big use case in this category, and an example might be insurance agents doing complex calculations for large clients on the spot in industrial plants. They need access to huge amounts of data it's not practical to load onto their local devices. Then there are the use cases that support real-time decision-making. Enterprises across industrial sectors want to do more operational automation to improve business efficiency and reduce risk. On fast-moving production lines or in rapidly changing situations, they need to collect and process large amounts of data to deliver an automated decision, with very low latency between these steps. Speed is key here. FedEx, for example, already sorts parcels within 2 to 3 milliseconds. Verizon often cites the example of the textile industry, where the speed of the printing machines means that it's imperative to spot the moment when patterns start being misprinted, so that the factory can take corrective action immediately and save hundreds of thousands of dollars worth of wasted material. And thirdly, there are the use cases that support the near real-time optimization of whole ecosystems. As industrial ecosystems become more complex, a feature that the COVID-19 pandemic has highlighted, it's becoming increasingly important for companies to have continuous, up-to-date visibility across the entire ecosystem in which they participate. This category of use cases will enable complex real-time decision-making at scale, of the kind Peachtree Corners has already hinted at, involving multiple companies and potentially millions of end users, such as vehicle occupants and residents. Now, as I've pointed out, data drives all these use cases, and as industries collect and use more data, Dell and others estimate around a 4-fold increase in the production of data globally over the next 5 years. Big data and the related technologies of analytics, AI, and machine learning are just one of the inputs to industrial transformation. There are many other technologies that enterprises associate with it, such as IoT, which is transforming pretty much anything into a source and consumer of data, from vehicles, drones, and robots to white goods and street furniture. Mixed reality and blockchain technologies are enabling new customer and business experiences. Cloud and open APIs are revolutionizing access to data, and 4 and 5G networks transform the cost of collecting data from many more locations than has been possible in the past. The maturing of so many new technologies at the same time is creating a perfect storm of opportunity for new operational use cases, and as we've discussed, these will generate massive amounts of data over the next few years. However, that data will need to be processed close to its sources for speed and security reasons, and these requirements are reshaping cloud and cellular networks. Instead of transporting operational data from locations at the edges of their networks to a central cloud for processing, Enterprises want cloud computing to be distributed to those edges instead, so that they can process data in situ. And enterprises want to harness the powerful qualities of cellular networks in a private, dedicated way to transport operational data securely to those edge locations and carry the decisions that result from that edge-based processing back to the relevant systems in near real time. Now, since operators own locations at the edges of their network, they're well placed to support edge computing. And of course, they're experts in LTE and 5G networks. In other words, operators can provide two of the key enabling technologies for industrial transformation. However, enterprises want use cases, solutions, and business outcomes. They're not interested in discrete technologies. Different kinds of players with strengths in different technologies are competing for enterprise share of wallet in the industrial transformation market, as we'll discuss later. The winners are likely to be those suppliers that can combine multiple technologies in flexible ways to meet a variety of industry requirements. And now I'd like to hand over to Michelle for the next part of our presentation.
Thanks, Caroline. So this brings us to one of the key challenges of these new opportunities. LTE and 5G networks are public networks and built to cater for the mass market smartphone business. Likewise, public cloud computing emerged to support multiple types of developers and enterprises at scale, with access to software resources and storage for their various IT projects. Neither public networks or public clouds lend themselves easily in their current form to supporting the highly bespoke and fragmented nature of enterprise requirements. Components of the cellular network and the cloud still need to be scaled down in terms of complexity and cost to cater for the enterprise effectively. They'll need to become easier to deploy and operate in order to compete with existing solutions such as Wi-Fi, and they'll probably need to reach similar price points to Wi-Fi as well. And at the same time, the cloud needs to move to the edge to meet some of the requirements that Caroline outlined, processing data in situ to allow for real-time decision-making. And of course, this has started to happen. Some challenger vendors such as Ethernet and Metaswitch have designed their products for enterprises from the outset. And Nokia and Ericsson are responding with solutions such as Nokia's NDAC and Ericsson's Industry Connect. But we hear that there's still a lot of progress to be made. So why is this happening now? Well, certain demand and supply side factors are coming together, and awareness of private wireless and edge computing as potential solutions is increasing. And I've selected here just a few of those factors. So cellular technologies are beginning to replace some older technologies such as Tetra as contracts come to an end. And cellular can provide a cost-effective and efficient alternative. And this is partly because cellular technologies are standards-driven, they have a future roadmap, and they benefit from an ecosystem of existing suppliers. And at the same time, there's been a big supply-side push as infrastructure vendors and operators seek new markets to grow their revenue. And for edge computing, while enterprises need agile data collection and local processing to enable the next steps of digital transformation, as Caroline has pointed out, and these needs are beginning to be met by cloud stacks being available on-premise that can run both compute and network workloads. So just how big is this opportunity? Well, we forecast that the total private LTE 5G network spend will reach around $8.5 billion by 2025. And this is the cumulative CapEx and OpEx over the 5-year period. Now, this doesn't include spectrum, devices, or solutions on top. And we believe that this market will build slowly. If we take the example of the IoT market, it has taken well over a decade to reach annual connectivity revenue of $7 to $8 billion, and it's still less than 1% of revenue for most operators. But of course, there are also other challenges. The challenge for 5G is that most industrial environments are brownfield sites. They already have a plethora of networking technologies in place, connecting existing IoT assets and driving current industrial automation processes. We believe it will take some time for 5G to displace these technologies, especially when you consider that the life of a factory is around 20 years. And our enterprise market survey suggests that companies don't yet see 5G as critical, and not as critical as, say, edge or edge computing to their digital transformation strategies. Total edge computing spend, in contrast, will reach over $40 billion by 2025. And our survey shows very clearly that spend will shift from the private edge to the public edge. Industrial demand for edge computing is gathering pace faster than for private LTE 5G networks. And again, our market survey shows a strong level of interest in edge computing and solid plans to invest in it, which is the basis for this market forecast. So now let's take a closer look at private LTE and 5G network deployments. So this data is a sample from our private LTE 5G network tracker, and the sample focuses on 101 private networks that have been publicly announced. Now, of course, there are more private networks in place, probably around 500, but there is little data in the public domain on them. So I've just chosen a smaller sample. And looking at the chart on the left, very few are operator-led or have operator involvement. Indeed, operators are the main contractors on just 16 out of the networks shown here, out of the 101 networks. And they play little or no role in the other 85 networks. In some cases, they may be providing spectrum. And it's true to say that operator activity in this market has been low, and it suggests that operators are struggling to identify what role they can play. And we've seen mainly those with large IoT businesses enter this market. Now, looking at the chart on the right, despite all of the publicity around private 5G, most networks today are based on LTE. And LTE has proved to be a very suitable technology to meet some enterprise requirements for in-building and campus networks. So now we'll examine a little bit why this is such a challenging area for operators. We've identified three main network models, and the first is shown here. The private LTE 5G network model today is predominantly an on-premise model and deploys dedicated radio and core components and typically a private edge. Now, Caroline mentioned that real-time decisioning use cases are being deployed, and these are being deployed today on this model. Now, for this model, operators can only assume a reseller role and partner with vendors to deliver their network components. They have less control over pricing and business models, and therefore less opportunity to differentiate their offer. And in addition, this is a crowded supplier market with vendors, systems integrators, and specialists entering the market. And in some countries, the operator's role is further diminished due to the spectrum regime. In Germany, for example, where industrial spectrum has been allocated. So increasingly, operators are considering new vendor partnerships, sometimes with challenger vendors, to offer new approaches, such as cloud-based solutions, and offer more flexible business models. But this model remains challenging, and it's difficult to see how operators can maximize value here. So with the next model, this is the hybrid model, and this comprises a combination of on-premise and public network assets. It's typically known as the hybrid model. Now, this allows operators to generate a greater share of the revenue because they can monetize their own assets, and it provides them with more flexibility in terms of the revenue models. And of course, there are many different combinations of hybrid networks that operators could explore, and I've just shown one here, which takes the public radio network and a dedicated on-premise core. Deutsche Telekom, for example, is providing a dual slice of its radio network to lighting manufacturer Osram with a dedicated core on-premise. Equally, operators could provide a slice of their public core, and Telefonica and Vodafone provide variations of this model using their public core network. But importantly here, operators are able to monetize their spectrum as well, and they can start to offer public edge services. Now, this model is not without its challenges, of course. Enterprises do not always view the public mobile network as suitable for meeting their needs. They're concerned about data privacy and ensuring that SLAs are relevant for their needs. So operators have a lot of work to do to demonstrate that this model can deliver. And our third and final model is an emerging model, which we've named the public industrial network. Now, we're not yet aware of any operators or other players offering this model commercially yet. But in this scenario, the operator, or indeed other types of players such as a neutral host, would deploy a separate network, either core or radio or both, solely to support enterprise use cases. The network would be multi-tenanted, but it would be separate from the public network and tailored for enterprise use, of course. Now, we are aware that some operators are exploring a dedicated enterprise core to serve the enterprise. But other providers, possibly providers such as Arqiva, Cellnex, that own spectrum and infrastructure assets, might also consider this approach. And as we've already seen, Microsoft made some moves towards this model with its acquisition of Affirm Networks and Metaswitch. I'll now hand back to Caroline to discuss in more detail the edge computing opportunity.
Thank you, Michelle. Well, enterprises cite the need for application resiliency, better customer experience, security and data sovereignty, and the cost of data backhaul to the public cloud as the main drivers for edge computing. But until a year or so ago, they didn't have a choice of where to run edge computing. If they wanted access to cloud infrastructure close to the edge of the network for operational purposes, for example, to optimize wind turbine blades in a wind farm, or to run automated guided vehicles in warehouses, they needed to build their own private edge clouds. However, our research shows that there's strong enterprise appetite for public edge computing, as Michelle has already mentioned, delivered from small, multi-tenanted clouds located very much closer to companies than the massive data centers typically owned by the public cloud providers and sited well away from centers of population. The public cloud providers themselves have realized this new demand and from 2019 onwards started to move into metro data centers, most prominently through alliances with operators for the latter's metro data center facilities. Verizon, for example, expects to have AWS public edge computing facilities co-located with its 5G network cloud in 10 US cities by the end of 2020. The interesting question is where edge computing goes next. Industry 5.0 use cases are likely to have more stringent requirements that can be catered for by public edge computing facilities, even in metro data centers. One of the world's largest insurance companies wants to use AI-based natural language processing to support completely natural-sounding conversations between chatbots and its customers. It points out that the round-trip delay between a customer in Belfast and a compute location in London or Dublin is simply too long to deliver this use case. And the company needs a web of public edge computing locations before its voice services can become a rich customer experience. Now, although it's early days for Industry 5.0 requirements, they are coinciding with the cloudification of 5G network functions, and specifically the virtualization of the radio access network. vRAN, virtualized RAN, and its Open RAN counterpart will push operators to build clouds much further out than the metro data center, even closer to their enterprise customers. Rakuten, for example, has already built 6,000 edge locations into its vRAN, from which it can start hosting enterprise applications when it launches 5G for enterprise next year. So we're expecting edge clouds to colonize mobile sites over the next 3 to 5 years to support both network functions needed for the hybrid model of private 5G networks and Industry 5.0 use cases. Now, this slide shows the current value chain for public edge computing, where operators provide the facilities and metro data centers, and the public cloud providers bring on-premise versions of their cloud stacks, their developer ecosystems, and their relationships with independent software vendors with industry-specific applications. The table shows the alliances different operators have with various public cloud providers, Azure being the most popular partner for the moment. Some operators, and Vodafone is the best example here, are hedging their bets and partnering with more than one public cloud provider for edge computing. Now, in this scenario, operators' ability to make money out of the edge computing value chain is largely based on colo and connectivity services. So they are going to, at this rate, only manage to achieve a small proportion of the $40 billion plus market that Michelle talked about earlier. We reckon around $6 billion of that. However, longer term, advanced operators harbour ambitions of providing a global operator-led public edge cloud that can run both 5G network functions and enterprise IT, OT, operational technology applications closer to the edge, as I previously described. Now, operators would need to cooperate on a global scale to create such a public edge cloud that could compete with the strong lead the public cloud providers have in this market. And I'd like to now turn back to Michelle to discuss the operator opportunity.
Thanks, Caroline. So I think we've established that operators are reasonably well placed to deliver their network and edge assets, although they face challenges, as we've both outlined. To capture more value, they'll have to leverage or build additional capabilities. Systems integration, for example. Many operators will be challenged to deliver systems integration expertise. A few, such as Deutsche Telekom and Orange, have strong systems integration departments to deliver on this highly bespoke opportunity, but many operators don't have these skills in-house. Operators with strong IoT assets may be better placed to differentiate their offers with horizontal and vertical solutions. Vodafone, for example, is building on its IoT.next investment to deliver a horizontal solution. But it's not clear that many operators have those existing capabilities to really exploit the opportunity further. And as we've mentioned throughout the presentation, this is a highly competitive market, and operators will come up against existing competitors as well as new competitors. Now, I've mentioned systems integration. Systems integrators, they are well placed to deliver private networks. And in Germany, for example, there's increased activity by systems integrators in the market who are looking to exploit the opportunity that has arisen from industrial spectrum. So if we take Mergler, a specialist systems integrator, it has been awarded its own industrial spectrum license, and it's going to deploy a private 5G network with its partner Mavenir for its own warehouse and logistics use cases. But it will also use it to showcase to potential customers its capabilities in delivering private LTE and 5G to potential customers. Caroline, are there any other examples?
Yes, I'd like to expand a little, Michelle, on what you said earlier about the towercos as neutral hosts. You mentioned Cellnex, for example, but of course in the States there's the example of Crown Castle and their investment in a edge computing company, facilities company called Vapor.io. So that's a very interesting and promising relationship that could result not only in a fabric of edge computing data centers, but also potentially moving into private 5G networks as well. And Equinix is also playing this kind of role. It bought an edge computing company again in Packet, and is strengthening its enterprise networking credentials. So very interesting from neutral hosts. You've also mentioned, obviously, the public cloud providers. We've talked about those. They have long-term ambitions to enable Industry 5.0. And they see operators, the operators have distributed networking and facilities that the public cloud providers see as important sources of the kind of expertise they themselves will need to conquer the much larger Industry 5.0 opportunity. And then, of course, with the new spectrum allocations around the world, we are expecting that there will be alternative edge location owners that are going to do interesting things both with edge computing and private networks. So we're thinking about owners of stadia, of theme parks, of buildings, of road, motorways, and so on, and big engineering companies. So a lot of potentially interesting competitors that could, as these technologies, as you pointed out, Michelle, these technologies are being democratized, they're being scaled down, they're becoming cheaper. The price points will be very interesting for new market entrants. So, in conclusion, then, the industrial transformation opportunity is going to be a tough nut for most operators to crack. They will need the right set of network and edge computing assets at the very least, as Michelle's pointed out, and then to drive significant value, they'll need to augment these assets with the cloud-native IT skills, systems integration, expertise, and knowledge of industry-specific operational use cases. Now, operators are unlikely to have all these resources in-house or even to invest in all of them themselves, so they'll need to build an ecosystem of partners to help them. Some operators are already doing this, as we've seen with public cloud providers in the edge computing market, for example, and with systems integrators and network equipment vendors in the private network market, as Michelle's pointed out. But to maximize their opportunity, operators should ensure they have a broad set of partnerships that will enable them to deliver use cases and business outcomes to customers, not just point technologies. Finally, operators will face their greatest challenge from competitors building public industrial networks, so they have a short window of opportunity to address this market. Operators should look at ways of delivering such a network quickly, with a high degree of automation, and at a differentiated price point from their LTE 5G mobile broadband networks, in order to seize the advantage here. Well, that's the end of our presentation. Thank you for listening, and please do send in your questions.
Thank you, Caroline. Thank you, Michelle. And let me say thank you to everyone who has attended and submitted questions throughout the presentation. We have quite a list. Sadly, we won't be able to get through all of them. There are just so many. However, any that we do not get through during this Q&A session, like I mentioned earlier, we will get back to you shortly in the coming weeks and days, really. So let's move to Q&A as we have some time left in the session. So the first question that I picked out earlier on was a delegate would like to know, what does the opportunity for edge computing look like in developing markets?
Yes, thank you for that question. We quite often get that because, of course, a lot of our research has been looking at the most advanced markets, because that's, of course, where it's most evident, where the investment is most evident. So a lot of our survey work, for example, as I said, focused on those four advanced economic zones of US, UK, Germany, and Japan, highly industrialized societies. The edge computing opportunity in developing markets is really sort of harder to ascertain, because, of course, a lot of what's driving the developed markets are things like automation. As I said, real-time decisioning. Automation is highly important because labour costs are high. To avoid the problems with supply chains, a number of developed market companies are thinking about onshoring, and in order to onshore their production lines, they are going to need to automate, and that's why they're so interested in edge computing and 5G, private 5G networks. Of course, that same motivation won't apply in companies where labour costs are very low, where perhaps the standards of health and safety are not as stringent as they are in other countries. So in those areas, we see less demand for edge computing at the moment, but there will still be some very large companies, retailers, mining companies, global multinational companies that will want to have the same kinds of operations round the world, whether they operate in developed or developing markets, and they will probably be the ones that will be pushing into those markets.
Okay, thank you, Caroline. That's great. So picking at another question here around the private wireless opportunity. So how does the private wireless opportunity differ both by country or by region?
Yeah, that's a very good question. Part of the reason why it does differ significantly is largely because of the spectrum regime in different countries, and I've already talked about this a bit in the presentation. I've mentioned Germany that has allocated industrial spectrum. And that makes it a lot more difficult for operators to offer their own spectrum as part of this opportunity. It diminishes the operator's role. In other countries, for example, the US, there's shared spectrum in the form of CBRS, and that is also lowering barriers to entry for many different companies to supply private networks based on shared spectrum there. So again, it does throw a little bit of a question mark over the role of operators. In other markets where operators are able to leverage their spectrum, then obviously there's a greater opportunity for operators, although of course we have outlined some of the challenges. So I would say at this point, spectrum is one of the key factors that sort of determines how the market differs. One market differs from another.
Okay, thanks, Michelle. Great. So we have still got time for a few more. So here's one I picked out a little bit earlier on. What strengths do operators have versus their key competitors?
Michelle, shall I take a stab at that, and then perhaps you can chime in? So I'll look at that from an edge computing point of view, and then perhaps you can follow up with private networks. On the edge computing side, I mean, the main strength is that the fact that they own so many valuable edge locations. They do have metro data centers, as I've said. They are pushing the cloud further out in their networks even, so that they've got central offices that they can use. So they've got a set of excellent locations that can be used for edge computing. They also are well used to running a distributed business. I mean, networks are inherently distributed. If you're a public cloud provider, you've been running a centralized business and getting your economies of scale out of that. Operators know how to deploy in a very distributed way. So that's, I think, another strength on the edge computing side. And of course, they do understand, they understand latency. They actually also, interestingly enough, understand the operational transformation that IT is bringing in, because of course they're working on that with their networks at the moment, and there's an analogy between what operators have been doing in bringing IT into their networks and what big industrial companies now want to do, bringing IT into their operational systems. So I think they do have they do have quite a few strengths in the edge computing market. Michelle?
Yes, well, with regard to the private LTE 5G market, we've outlined a large number of challenges that operators face, but obviously in markets where the industrial spectrum hasn't been allocated, they're able to use their spectrum assets. But I think one of the points that we haven't touched on much in the presentation is the wide area public network. So private LTE 5G tends to focus on that sort of in-building and campus network play. But of course, many of the assets that enterprises are supporting will also require wide area connectivity. And network operators are obviously in a good position to provide that roaming, if you like, from the private network or the campus network onto the wide area network. And this could become increasingly important for connected products and solutions, for example. So that's another strength where that operators do have.
Great. Thank you, Michelle. Thank you, Caroline. So I'm conscious that we do have, obviously, today's second keynote kicking off in just over 15 minutes. So I think really on that note, we'll wrap up there. Like I'd mentioned earlier, apologies for not getting through all the questions today. There are just so many, and we will follow up with you shortly. So really, I think I would just say thank you very much to today's speakers, and thank you very much again for everyone who attended this session. The next keynote will be kicking off, like I mentioned, in just over 15 minutes. To get to that, all you need to do is go back to the event homepage via the widget that you'll see on your screen before you, and we look forward to seeing you there. Thank you very much for attending this session, and see you later. Thanks again. Bye-bye.